Hi, welcome to my channel. Today we are going to take a look at recursive SQL queries. Recursion in programming is a technique where a function calls itself to solve a problem by breaking the problem up into smaller and simpler instances of the problem itself. The whole notion of recursion comes up fairly frequently if you're a programmer, but it doesn't rear its head all that often if you're, say, a data analyst who works primarily with SQL. However, it's useful to know because there are instances where you're working with hierarchical data, especially like, say, an organization structure or a family tree. And if you're querying that kind of data, knowing how to construct a recursive SQL query can come in very, very handy. I'll explain the concept to you and I'll also demonstrate it to you through a live coding example. Let's dive right in. This is the data set that we'll be playing with. The table is called employees. It has three columns: employee ID, name, and manager ID. Each row represents an employee in a firm. Employee ID is the employee's ID. Name is self-explanatory. Manager ID refers to the employee ID of that employee's manager. So if we go through these rows, Alice Johnson does not have a manager. She's probably assumed she's the CEO of the company. She doesn't report into anybody. Bob Smith, employee ID 2, his manager ID is 1, which refers to Alice Johnson. So that means Alice is Bob's manager, and so on. And there's also a notion of hierarchy here in that, let's take David Thompson. His manager is 2, which is Bob, and Bob's manager is Alice. So in terms of level, you can consider Alice to be at level 1, Bob is at level 2, David is at level 3. So what we want to construct is a query which outputs employee name, manager name, and the level. Now the first two you can actually obtain without using recursive SQL, but although you can do it with recursive SQL as well, but it's really the last one where it becomes much easier if you know how to construct recursive SQL. So with that, let me explain to you the general structure of a recursive SQL. To write these, one of the things that you'll need to know is common table expressions, or CTEs. Now, if you don't know what CTEs are, drop me a note, drop me a comment, and I'll create a video explaining CTEs. But the way you write them is this. The new keyword that gets used here is recursive, which tells SQL that this is a recursive CTE, and then give the CTE whatever name you choose as. Now there's a notion of an anchor query, which retrieves the first row on top of which the recursion runs and builds the subsequent rows. So from whatever this is, I'm just showing you the structure here. Don't worry about the specifics. And then is the recursive call, which is combined with the anchor query. And this is how it gets written. So it's recursive, and by definition it refers to the CTE itself, name, and very often this will be joined with some other table depending on what the case is, and so on. But this is the general construct, and then like with any other CTE, you select whatever you need from the CTE that you just coded. So this is the general construct. Once again, you tell SQL that this is a recursive CTE by using the keyword recursive. The anchor query is written first, and then the recursive query, and those are combined using union all. So let's now see how we can use this in our example. So let's start writing the recursive query. Recursive as recursive, give it a logical name, emp-h as, here's the base query. So for the base query, we want to retrieve the top level employees. So employees that don't have managers. So select star from employees where mgr id is null. The columns you want to retrieve are emp id, name as emp name. I want two names because one's the manager name, and level 1 employees don't have managers, hence I'm hard coding these values. Just retrieve null as mgr name and hard code their levels as well. Now if you run this, you'll get only Alice Johnson. Yes, so that's right. Now you come to the recursive part. Union all, select star from, so recursion, and hence you're making a call to the same CTE. Now think about what this is doing. In the first execution, the base has run, it's retrieved Alice Johnson. Now you want it to join emp-h Alice Johnson against the employee table and pull all the records where Alice Johnson is the manager. So you do that by doing an inner join with employees. I'll call this EH and this EE based. Now think about how you're going to do this join. EH dot emp ID equals EE dot manager ID. And what do you need to retrieve from here? You'll have to retrieve EE dot emp ID, EE dot name as emp name. Now EH dot name as manager name, and now the level is, if you have the manager's level, which is EH dot level, you just add 1 to it to get the employee's level, because if he or she is reporting to that manager, his level is automatically 1 higher as level. And this, I believe, should give us the results we are looking for. Oops, there's an error somewhere here. Not EG, EH. Oh, the problem here is there is no, we renamed these columns, so it needs to be EH dot emp name. And that's our result. So Alice, no manager, level 1. Bob Smith, Alice is the manager, level 2. Charlie Brown, Alice is the manager, level 2. Dave Thompson, as we saw previously, Bob Smith is the manager, and since he's 2 levels down, his level is actually 3. So that's how recursive SQL works. Just to drive home the point, let's look at a more traditional example of how do you calculate factorials with recursive SQL. So with recursive, let's call it factorial, as suppose you want to calculate factorial of 5. Select 5, that's your base case. Union all. Let's see how you do this. Select star from factorial. Now as, let's call this n, and this is as, this is yeah, this is the factorial, this is the level. So star where n should be greater than 1 and n minus 1. Oops. And this factorial should be facts times n minus 1. Now if you select factorial, star from factorial, star, of course I've forgotten how to type. Got to be careful with this stuff. So 5 factorial is 120. So, you know, it goes down the entire list and the last value is 120. If you just want to see what the factorial value is, you do fact where n equals 1. Cool. Hope you liked the video. If you did, give it a thumbs up and also subscribe to my channel. Thank you.